Hello, everyone, and welcome to the Nethermind stream on Fusaka upgrade of the Ethereum chain. We have guests here who have contributed to the Fusaka upgrade, and we will be talking with them and discussing the upgrade with them. This upgrade was had a theme, and the theme was L1 scaling, L2 scaling, and DevX and UX, user experience and developer experience. Later on, after we discuss these sections, we will actually also take a look at the actual fork and try to see it live. And later, afterwards, we will talk about what's next for Ethereum in the upcoming fork, Amsterdam. We have contributors from different teams, CL teams, testing team, DevOps teams, and even some L2 guests from L2 development teams. Starting with the first section, we're going to talk about the challenges of testing and DevOps related to the upgrades, and Camille will drive that conversation. Camille?
Thank you, Ahmed. So in this segment, we want to talk about the journey of preparation to the hard fork from the perspective on free infrastructure, testing, and general readiness. Here we have two amazing guests, Barnabas, a DevOps engineer from ifpanda Ops team in Ethereum Foundation, and Mario Vega, a team lead of Steel team, testing team from the Ethereum Foundation. Hi, guys.
Hi. So,
great. So let's start with our headliner, actually. So PeerDAS. So I was thinking, and it's more like an open question to you both guys. What was the hardest challenge to go through this like kind of groundbreaking feature, which is changing our networking layer on CL side quite a lot?
Yeah, so I will get started. I was basically responsible for making sure that Fusaka can ship in this year. So our overarching goal was basically trying to test as much as possible parallel to the previous fork as well. We had developers working on Fusaka for over a year and a half at this point. One of the major problems that we introduced is the fact that we now have supernodes and full nodes, and this basically just doubled our testing infrastructure because till now we just had to run everyone was like a supernode. Everyone had all the data. Everyone was participating in the network in the same share. Now, going forward, we split it up to two tasks. We had the supernodes that were beefier machines that was demonstrating that you have the nodes that have all the custody, all 128 columns. And then on the other side, we had the full nodes that were basically the home stakers, and we were making sure that Fusaka will basically work for the home stakers and for the supernodes as well. So this means the testing metrics grew from 35, which was our previous. Well, we went from 30 to 35 with the introduction of testing Nimbus CL as well. And then, well, we went from 30 to 35 with the introduction of testing Nimbus CL. So each of the DevNets were basically running 70 nodes with different EL and CL. Some unique features and unique new stuff that we had to work on is basically visualizing the columns. I can show you quickly by sharing my screen. Just give me 1 second. I have too many windows apparently. Can you see my screen?
Yeah, we can see it.
Right. So yes. In the top here, you can see each of the custody columns. This is right now showing Fusaka DevNet 3. Showing this on mainnet is a bit troublesome because we have just too many nodes to visualize this. So we have 128 columns, and here we can see that we try to represent that each node is custodying which specific column. So this was very, very helpful early on to be able to determine if the custody group section is actually working the way it should. Then later on, we also added validator custody requirements by introducing the Desk Guardian. So in Desk Guardian, we can actually sample random slots and determine and figure out if the given node is custodying the correct columns or not. And here you can see that we just sampled these 4 random slots, and this specific node is custodying 11 columns out of 11. So this is all correct. And these tools, yeah, I will just stop sharing right there. These tools were basically made from ground up to enable us to visualize what is happening on the network, and they were very, very helpful to find early bugs and even bugs later on down the line. Regarding the changing of the networking layer, we had to introduce ways to be able to limit a specific machine and how much bandwidth a specific machine can have in order to be able to mimic a home staker environment. This was also, we had to create a new tool for this. It's called BreakBear. And this basically limits all the traffic between a Docker interface and not like very specific Docker containers and not others. So this way we can still push out logs on the main interface, but the execution layer and the consensus layer containers were limited to 50 megabit per second without touching the engine API containers.
Yeah, so this seems like quite a lot of effort was done just to test one of the EAPs, like plenty of tools were even created, invented from scratch to go through this. I was curious also, it was like, so we have plenty of new tools, but was there any like infrastructure challenge, like some much bigger scaled networks which you spawn up just for this purpose of the peer dust?
Yeah, so as we introduce more blobs, more storage will be required, especially for supernodes. So that just means testing will become a lot more expensive because we need to get machines that have significantly more disk than on the test before. So this is already a problem on DevNet 3. We have that network running for like a few months already, and the disks are just keep running out of disk. We also did a couple of very large networks where we run 1,500 nodes in collaboration with which team was it?
Sunny Labs?
Sunnyside Labs, yeah, with Sunnyside Lab guys. And there we were basically trying to figure out what are the correct blob values for the target and max going onwards with Fusaka and after.
Yeah. Yeah, so PeerDAS is really like pushing our limits and invention of tooling and even infrastructure pushing us to the limits. But this shows that you guys put a lot of effort to make it tested as much as possible. So moving forward, aside of PeerDAS, I was curious to hear from Mario. Like PeerDAS, we all know was super hard and super intensive to test. But I was curious if there was something aside of this throughout all of the APs, which was increasing your complexity of testing quite unexpectedly.
So I think if you think about it, like Fusaka was a little bit simpler in terms of EVM changes. There were like simple one-line changes, but they did have like a lot of impact in testing. One that was not like kind of unexpected is the BPO forks. For example, this is something that we struggle a little bit with the specs testing because we were really not prepared for such type of forks. This had not happened before. And actually this PPO forks was one of the main catalysts that we decided to finally produce what we called the wealth. Prior to Fusaka, we had tests and the specs in a different repository. And so this year, what we did was we did this project where we basically merged both of the repositories together. And now the specs and tests are put together in the same repository, which means that for everything that you want to spec for this and future forks, you're gonna need to take a look into the tests, right? So the VPOs were one of the catalysts. There are many more catalysts. This is a project that we wanted to do for a very long time, and it was finally completed on October this year. And we're really proud about this effort. That it was a lot of complexity because it's two different repositories, two different code perspectives. And so it took a lot of effort from the team, and we're really proud of this accomplishment this year. Also, this year, something that did not seem possible in previous years was the benchmarking. We started working on using the specs to fill benchmarking tools. So this was done to try to produce like the reference tests where we stress one very specific aspect of the EVM to the limit, and we fill a block, only doing that over and over again, right? So prior to this change that started happening during the Berlin interrupt, I don't think we never thought this was going to be possible, but we are now like we have a very comprehensive set of tests, benchmarking tests that the clients use and consume to try to see what are the bottlenecks in their clients, in the execution clients, and see how can they achieve better performance. So those were the two things that we accomplished this year, basically for this fork. It's gonna keep helping us in future forks, right? It's not gonna be like the last thing that we update for benchmarking or for VPOs, for example.
Mm-hmm. Yeah, amazing. So like smaller EAPs, which just from the description look like small changes, are triggering some huge reworks or huge efforts behind the scenes, which might went unnoticed, but hopefully it will help us in next forks for sure. Thank you, Mario. So moving forward, I was also thinking like it's to both of you, which kind of DevNet, if you can say that, like which kind of DevNet gave us an impression that, okay, at this moment we are heading into the really proper direction, because of course we have last DevNet, which is confirming everything is working as expected. but there are plenty of things are moving in different ways throughout the development. So I was curious if you have any like a spotlight from the past, from the development phase.
I would say in Berlin, when we had the Interop event, we came up with the earliest available slot, which was one of the key features that were missing from the CL side in order to figure out syncing and without penalizing other nodes from not serving the data that they claimed that they would have. This basically allowed us to have the Berlin Interop DevNet 2, which was basically a feature complete in terms of PureDES functionality with the earliest available slot. And then we had the Fusaka DevNet 3, which is still online and still running the latest spec, and it is still finalizing and it's still stable. So I would say at that point, the earliest available slot is what really unlocked us in order to be able to start going forward into forking testnet and scheduling mainnet as well.
Great. Yeah. So
this is only on the PureDES side. Like we had 12 other EIPs that had to be also tested, but I think everybody agrees that PureDES was by far the most significant EIP to be worked on Fusaka.
Yeah, it has quite a lot of things to organize, not only from the terms of specification, but also from the terms of like orchestrating everything. So I guess Berlin Interop was like the place where we sat together, everyone sat together, and we were able to push forward, like fast forward plenty of the things to push it better and faster. Great, thank you. So moving forward, like was thinking if you can recall anything Fusaka, like any Fusaka related improvement which we did during the Fusaka preparation, and you wish if you could backward the time to start this initiative earlier, if possible.
I can take that. I feel like benchmarking, just to bring it up again, I feel like this effort was only very visible for us that we had to do it during Berlin Interop, but I feel like this could have been started, and it was like an idea that had been floating around. Some people from the Epsilon team brought it up that they wanted to do benchmarking, and it's something that I personally didn't see like possible. I wish we had started this effort a little bit sooner, but I think it's still a great time. There's still a lot of scaling to do. There's still a lot of, and the new features that come in the feature forks, we are also going to have to extensively benchmark those. So it's not too late. I mean, it's I think it come in a great time. It would have been better sooner, but it's great nonetheless. I don't know, Barnabas, do you have something else?
It's very hard to say. There has been so many challenges, and yeah, if we knew all the challenges before we started with it, yeah, we would just not even get started with it. So like, it's very hard to say what we could have done earlier. I think we still managed to ship Fusaka in the same year as we shipped Vectra. So I think that's already a very big achievement, and it's not something we could have done, I think, even a year ago. The amount of pipelining we did for Fusaka is just amazing.
That's amazing that we are shipping the second huge upgrade for Ethereum, and in the meantime we are working on another one which will be as big as those two together. So this is like an amazing achievement and great improvement in our processes. And yeah, great to hear that benchmarking is like an effort which is improving our like way forward better, and we'll be collaborating further to make it better and better and for each fork. So yeah, so this is kind of a similar question, but do you have any like lessons learned from preparation to Fusaka right now, and something you want to improve for Glamsterdam, for example?
I do have one very, very good one. So for example, there was this EIP that is introduced now in order to limit the gas amount that a single transaction can have. It's the EIP 7825. So that one, it breaks an invariant that has been in Ethereum since the very beginning, which is one transaction can consume everything, as much as gas as you want. from the block without limits, right? So we've been writing tests for 10 years without having to limit ourselves in terms of gas. And this thing just changed it all. It's a one-line change in most clients, but for testing, it was brutal. We had to go over like 10 years of tests, static tests, and we had to lower the gas limit in each one and also make sure that we didn't break anything. So we basically went into the tests and we had to compare the tracings before and after we made the change just to make sure that we didn't break anything. So the big lesson learned is that you have to basically parameterize or account for invariants being broken for future forks. That was one of the, I mean, to be honest, we saw it coming, but we are getting better at parameterizing, at making tests future proof, and so on and so forth. So yeah, I think that was a big lesson learned.
Yeah, that's pretty interesting, right? That is, you have an API which actually, from the implementation perspective, is like just a few lines of code to limit something. Then you have research which needs to take quite some time to actually analyze everything and ensure that this particular value is okay. And then behind the scenes, it is probably unnoticed by everyone, the complexity behind the tooling, which was never like maybe ready for that because it was never in the spotlight to do something like this. So like small EAP is changing a lot, but it's actually good because like we are catching the improvements, you're guys catching an improvement, which will help us in future to avoid such things. Great. So
let me just also bring up something that you know, I think there's lots of things that we learned from doing Fusaka in a way how we did it regarding the pipelining, and the whole way that we set this up to be able to parallelize work on it and have someone always working on Fusaka is something that we definitely want to keep doing forward. And we want to make sure that the next fork is also going to be parallelized just like we did with Fusaka. And then we're going to be able to have someone already look at the H fork even before we start shipping Amsterdam.
Yes, I guess that's one of the factors why we were able to ship Amsterdam, Fusaka this year, right? So having few teams parallelizing their efforts to actually test, develop, make a research, and push it forward. So that's way to go, and maybe we'll even be able to ship more per year if we'll make it better. Great. So one question, actually last question to Fusaka. I was thinking from both of you if you can share your underrated gem of this Fusaka hard fork, because everyone is talking very, very loudly about PeerDAS, but there is like multiple EAPs here, and I was thinking, aside of PeerDAS, do you see any EAPs which are very underrated yet bringing a lot of value?
ETHConfig. ETHConfig is such an underrated EIP. Basically making sure that all the execution layer clients are using the same config. It caught so many bugs before we hit the first testnet event. Like it's such an underrated EIP. It shouldn't have been an EIP. It's basically a JSON RPC endpoint on the execution layer client, but we actually enforced that everybody is using exactly the same syntax as everyone else. So we could basically just compare string to string, JSON to JSON.
Okay. I see that Mario strongly agrees with that.
Yeah. Also, maybe blob-based fee bounded by execution cost. I think that's going to be very interesting to see how the market plays out in terms of the blob fee market plays out after this. It's going to be very interesting.
Yeah. So two relatively, I mean, not small, but one which improves like interoperability between clients and how they communicate and how they share the configs, and the other which will improve the fee market for blobs, which is really interesting. I actually have quite a few tabs already open to see how the blob fees will react right after the fork, because this is like super interesting with some pages which are simulating what would happen in the past if this will be already enabled. So those two are actually also on my list. Great. So the last question, as we need to switch slowly to the other segment, is like, can you guys hint us a little bit about the preparation for Amsterdam? I know it's already in progress, but I was curious if we have already some nice milestones, nice progress, which we can share with our public.
Yes,
I
so we
can
said,
show.
oh, sorry. Go ahead, Mario.
Just quickly, the I think block level access list is gonna be great. We're still we are already working on it for the test and spec side, and Tony is here also. He's been amazing shielding this EIP. I think it's gonna be an amazing improvement to Ethereum in general. Parallelization is coming.
Great. Barnabas?
Yeah, so EPBS, the spec is almost done. The tests are pretty much done as well. We are waiting for clients to basically finish the implementation for the scope of DevNet 0, and then we can start launching testing on it as well. Hopefully, you can do that before the end of this year. It's just up to the client needs at this point.
Yeah, so we have Fusaka, which is already scaling everything quite a lot and opening the doors for better scalability of our L1 and L2. And then we have Glamsterdam, which is opening those doors even more. So that's the bright future from the scaling efforts which we have right now. So yeah, thank you very much, guys, for being there and sharing your thoughts about the preparation for the fork and readiness. Everything seems like it's very well battle tested, and everything was reworked to make sure that Fusaka will be a huge victory. Thank you very much, guys, for sharing your opinions. And now giving voice to the Ben Adams with second segment for actually scaling L1.
Hey, so this section's called Scaling L1. For the last few years, the Ethereum scaling story has been very roll-up focused, pushing the execution off the L1 and keeping the base layer conservative and boring. With Fusaka and this batch of VIPs, we're doing something a bit more direct to the L1 itself, tightening gas rules, putting hard bounds on worst case behavior, and then using that safety margin to raise limits and give protocol more throughput headroom. Before we jump into the spicy gas limit questions, let me get to the panel to introduce themselves. Marius, do you want to start with a quick intro, who you are, which kind or part of this stack you work on, how you've been involved, then Tony, Julio, and then Lukasz. Oh, we can't hear you, Marius.
Oh no, Mike Dow.
Do you want to go, Tony? While we wait for Marius?
Yeah, I can go in the meantime. Yeah, hello everyone, excited to be here. I'm Tony, I'm research engineer at EF, I'm lead of the protocol prototyping team, and I have been involved in this Scale L1 efforts very recently with some smaller EAPs around call data price increases. For example, the one we shipped in Pectra 7623, then contributed a bit to some analysis on the EAPs in Fusaka, and of course, block level access lists in Amsterdam.
Julio?
Hello, I'm Julio. I am the lead of the Aragon team. I am responsible for some of the EAPs that reduce some of our limits on Ethereum for Fusaka, and that allows us to scale further than 60 million.
Lukasz?
Hello, I'm Łukasz from Nethermind team. You can call me a tech lead in Nethermind team. I'm involved in multiple scaling operations, both in Nethermind as well as working on spec on collaborating on the APs.
Marius, is your mic? Hi. No. Oh, maybe.
You called me, Ben? Sorry.
No, Marius.
Some is coming from him. Maybe there is hope.
Okay. Tony, when people hear scaling the L1, they may have concerns about centralization risks. What's the core philosophy behind this batch of VIPs? Are we truly scaling the L1 or just removing inefficiencies and blockers?
Yeah, this is a good question. I guess it very much depends on how we scale the L1 in the end. Because of course, the simplest way to scale the L1 would just be to increase the hardware requirements. Everyone must have like double the number of cores, double the number of RAM, double the number of storage, and so on. And this would be basically the simplest way how you could theoretically scale the L1. But on Ethereum, this is like not the way how we want to do things. So one of the core principles behind scaling the L1 is always to make sure that we still maintain geographical decentralization, because that's super important for many properties of Ethereum, like credible neutrality, censorship resistance, and so on. And therefore, we didn't take like the shortcut, which would have been increasing the hardware requirements, which is easier to do, but on the other hand, you also lose all of those nice properties. So when we talk about scaling the L1 on Ethereum, it's very much focused on how can we kind of squeeze out efficiency from our existing hardware requirements. And the hardware requirements, there is an EAP for it. They are clearly defined. So we know exactly what validators, full nodes, local builders, and so on, what hardware they are running. And based on that, we try to scale the L1. And then it's, of course, a question of where are the existing bottlenecks? Because many things on the EVM today can already be scaled quite aggressively. But of course, as soon as you increase the gas limit, certain worst cases will turn even worse. And if we don't mitigate the impact those worst cases have on user experience, then I would say we have failed in actually scaling the L1 while maintaining all the nice properties that we love.
Can you guys hear me now?
We can hear you now.
Yeah, it works.
Perfect. Sorry for that. I just had we had a movie night and I used my laptop for it, and somehow all of my audio settings got messed up. Let me quickly also introduce myself. My name is Marius. I am working in the guest team and recently started co-leading the Scale the L1 track at the Ethereum Foundation together with Tim and Ansgar. And I think Tony has already answered that question quite beautifully. If I can only add one thing, I recently looked at our nodes. Like we had this amazing Dev Connect in Buenos Aires, and we brought a node there, and we had like a small little stand, and like you could see the node running, and then we realized that the node is not doing anything. Like if you really look at the node and you really see how much CPU and RAM and everything it uses basically barely anything. Every 12 seconds, there's like a little peak in the graph, and then it's empty for the next 12 seconds, and there's another little peak. And so a lot of the things that we are trying to do in Fusaka and Glamsterdam are trying to, as Tony already said, is trying to utilize the existing hardware better that we have. Right now we are only really using it in very like peak scenarios, but we don't have like sustained load on it, and we would like to, before we start increasing the hardware requirements, we want to make sure that we are utilizing all of the existing resources that we have. And so repricing is trying to improve that, and block access lists are trying to improve that, and EPPS is trying to improve that. So very exciting. And basically what people can take away is we are not trying to force you to buy new hardware so that the network can be faster, but we hope that we make better use of the existing hardware that we have.
Thank you. EIP 7825 introduces a protocol level cap on gas per transaction of 16 million gas. So no one transaction can consume an entire block. Julio, before this cap, were there DDoS or griefing scenarios that worried you, and how does it close them off?
So the actual initial motivation of the AP was more like just limiting the potential worst case if we went higher with the gas limit. The thing is that if you have a protocol as complex as Ethereum, tracking what can break what is a very difficult problem by itself, right? So you need and when you increase the capacity, you get to a point where you have you increase essentially the attack space. With the initial motivation of the AP was actually to put it to 30 million and say, okay, this is how much we can allow people to mess up with the chain, mess up with the transaction. If there is some OP code on precompile that explodes quadratically, they can only do as much damage, right? As an example. Then people realized that it was actually also good for ZKVM, and it also had good parallelism properties. You can parallelize transaction much easily. You have better properties to the chain because you won't have a one block transaction after 30 million block, right? So then we decided to actually put it down to 60 million instead. So it went from 30 to 16. So in reality, it's more like it allows for better parallelism, and it doesn't really fix anything immediately, but it makes analysis much easier. Although as previously mentioned, it was a pain to test, but that's life, I guess.
Well, thank you. And following on from that, EIP 7934 adds a hard cap on the RLP encoded block size. So blocks can't be arbitrarily bloated with cheap transactions, even if the gas allows it. Gas measures computation, not bytes on the wire. What was the disconnect in this model with the new regime of scaling the L1?
So the reason why that IP came even to life was that there was essentially a limit in how big blocks could be on the consensus layer side. So if blocks were too big, more than 10 megabyte, they wouldn't be gossiped through the consensus layer, and people could just do it. And the only reason why we didn't see it is because the gas limit was low enough. We found that there were potential attacks if you increase the gas limit. So really, we were capping the gas limit not because of computation in that case, but because of an arbitrary limit. So essentially, what the IP does is completely removes the possibility of creating invalid blocks that could cause some form of DDoS, and allow for us to focus on computation and not having to worry if blocks too big are going to be so big that they cannot be gossiped, right? And the reprise called it all the time, for example.
Thank you. The IP 7823 and 7883 give mod XP upper bounds and also a pricing increase. Łukasz, how much did the repricing depend on real profiling data from implementations?
Yes.
And how confident are you that it still lines up with CPU costs across different clients?
So actually this repricings came from the testing vectors that especially Marcin from our team we're crafting with also collaboration with some OGs working on EVM like Paweł Bylita. But we at Nethermind, when we were starting to do our benchmarking, which we have now very good suit, very early discovered that ModX is a really an easily hit bottleneck for us, that we can easily craft and I don't want to say malicious, but very unfavorable mod XP scenarios. So, for example, before Fusaka, if someone would fill a block with those mod XPs, it could take Still reasonable amount of time with current gas limits, but quite long to process a block, and we couldn't go any further beyond what we already have, beyond 60 million, with those timings. Thankfully, the calculations are mostly predictable because they somewhat predictable at least because they are dependent on the length on the exponent mostly. So the changes that were introduced are focusing on making those large exponents way more costly. And we were also trying to figure out if this is being used on the chain, more or less. And we found out that this is very marginal usage on the chain, extremely marginal, so it won't really affect any users. It just addresses the worst case, possible cases. This and actually limiting to the transaction gas limit allows that because then we can also potentially parallelize that. So that's even less of a problem, especially when we get balls, then it completely stops being a problem because we can get perfect parallelization. One last thing I want to mention, because someone can say, why just you don't make the code faster and solve those modex opcodes calls faster, calculate them faster. Actually, this precompile uses very highly optimized code in all the clients using very fast to the metal libraries, so we just couldn't make it faster. It's just maths that take time on CPUs, and that's pretty much it. So there was a lot of optimization in some clients that allowed us to get to 60 million. That's why we didn't go to 60 million right from the start, like right half a year ago. We first went to 36 million, waited for a few clients to optimize their modex implementations, and now we went to 60. But we couldn't get anything more without proper repricing. That's the limit for us.
Thank you. EIP 7935 has the client defaults push the mainnet gas limit from 45 million to 60 million. And that came out with the Fusaka releases, and mainnet's already at 60 million. So, Marius, gas limit debates have historically been quite spicy. What has changed in the last few years that means 60 million is a comfortable target rather than a reckless one?
That's a great question. We have spent significantly more time doing benchmarking. I think it was already touched upon in the previous segment. But this is an effort that has been going on for, I would say, about 8 months now, and we have that has never been a focus before. We have never done extensive benchmarking of the whole EVM and all of the little parts within the EVM that could potentially break at higher gas limits. And so doing these benchmarks gives us a much better, much clearer view on what the EVM is capable of. And what we've seen in the past was basically other chains just taking all of the knobs that we have in Ethereum and like turning them to 100, and that is their path to scaling. And we've seen that this isn't working. State growth quickly becomes a problem. It is very hard to run nodes, to sync up to the network if the network is moving too fast. And so what we've seen and what we now benchmarked is that slight increases are possible, and 2x is a slight increase. It is very far from where we would like to be and where we will end up. So there's a lot of bigger increases in the pipeline. But they require us to limit things like state growth. They require us to think differently about how state should be handled. Yeah, someone said that Solana has like 200x the compute, but a similar state growth rate. And so this is where a lot of these early improvements will happen, is in just making compute much cheaper compared to state growth, and also trying to make state growth not nearly as bad as it is right now for some of the clients. These improvements together will allow us to increase the state, to increase the gas limit significantly. The debates were always so spicy because the system back then wasn't able to handle the amount of gas that we are pushing through it right now. If you look at historical gas charts, the gas for a long time was at 2 million gas per block, and so even the increase to 30 million was like a 15x, which is quite incredible. So we are just getting a lot better at writing the software. I think that is also a point. We're getting a lot better at writing the software. We're getting a lot better at figuring out the issues and benchmarking them, and we are getting better at changing the protocol slightly through things like, for example, the transaction gas limit cap. We're changing the protocol in tiny ways that have a huge impact on how much we can scale. And yeah, we as Lukas put in the chat, we are it's just accumulation of the years of improvements that we are seeing happening right now. And it's really great. It's really exciting, and it will go on for much further than where we are today.
Thank you. Tony, historically, we've relied on just make it more expensive to control the attack surface. What pushed the protocol from purely economic throttling to also add hard bounds with EIPs 7, the previous EIPs that have been like hard cap, blocks transactions?
Right. Yeah, so of course, if there is an open attack surface or something that behaves like a worst case, easy thing to do is just repricing that opcode. We did that in the past, and we will also continue doing so in the future. But those specific caps that you just mentioned, like 7.825, 7.934, are just like additional safeguards that protect the network from certain DOS vectors that might not even be clear at first place. Because as Julio mentioned very well, it's a complex protocol, and it's difficult to even determine what the worst cases are, right? One might think, okay, if I call like one opcode as often as possible, this might be the worst case, but sometimes there affects one opcode affects another thing, and there are things like state growth, bandwidth. So there's so many variables, and it's just difficult to even tell what is the actual worst case we're dealing with, and there are many of those. So 7.825 was originally just a simple cap that allows us to at least do benchmarks and not like throw those benchmarks away a week later when the gas limit increased, by just putting a cap on transactions and being able to determine like what is the worst case for a single transaction. Then with continued demand for L1 scaling and parallelization coming into the picture, 7.825 also had this additional effect that it bounds transactions to a certain gas limit, and by doing that, we can guarantee a certain parallelization in the future. For example, in Amsterdam, with ePBS being shipped and block level access list, there will be a lot of time within the slot where we can actually do something. As Mario said earlier, today the node is actually not doing much most of the time in the slot, and this will change in Glamsterdam next year. And Fusaka is already like a very good preparation for this fork too. So it sets the ground for further scaling. For example, if we would have not shipped 7825, the transaction gas limit cap, then the worst case would just have been like one very big transaction in the block, and we cannot parallelize one big transaction, right? We would have to split that transaction up. This is like even more complex. So what we achieve by putting a cap on the transaction gas limit, we will be able to guarantee a certain level of parallelization. So no matter what happens, no matter how bad the block look like, we should be able to parallelize the block execution and evenly distribute the work over the available cores. So at first glance, it looks very simple, especially thinking of 7825. It's, I mean, simple at least from the specs and client implementation, but we already heard from Mario that there are other places where it's actually not that simple. But it looks super simple, but we will see the impact of this EAP, especially next year. So this was a first stepping stone, and next year there will be like huge impact by this specific EAP, because this is the EAP that guarantees parallelization next year. And yeah, Lucas is asking if this is my favorite EAP of the fork. I definitely think it's an important one, and I'm super happy that Julio brought it up so early, because I think this is it sounds simple, but it's actually very, very powerful. So people might underestimate the effectiveness of this EAP, and it's not only helping us today, but it will even be more useful tomorrow.
A question for everybody on the panel. So these EIPs make the base layer tighter and cleaner, but at which point do further L1 scaling run into fundamental limits like state growth, latency, or economics? And where would you personally draw the line? Marius?
Sorry, let me read the question again.
Where would you sort of personally draw the line on scaling the L1? Since you've already mentioned some of these points.
Yes, I think the biggest thing that is currently an unresolved issue is state growth when it goes into like the terabyte scale. Like if we are growing by I don't know, a terabyte a year, then keeping up with that as a node operator will be pretty hard, pretty difficult, and also keeping that up as a database engine is also not easy, because you have to be able to access multiple terabytes of state in a very short period of time, in like less than a millisecond for one state lookup. And so there are definitely boundaries that especially when it comes to state, when it comes to compute, we are, in my opinion, very far away from touching these boundaries. As Tony already said, we have this EIP for a minimum requirement, hardware requirement for nodes. These minimum hardware requirements will most likely change over time. The hardware requirements we have right now, I think it's 8 cores, 16 gigabytes of RAM or 32 gigabytes of RAM, and 2 terabyte or maybe 4 terabytes of disk space. Like these are very modest requirements. As we see tech progressing and hardware capabilities progressing, we will also be updating this EIP, and we will also have much more headroom for scaling. we always have to make this trade-off between decentralization and scale. And to me, it makes no sense to err on the side of scale. We always have to err on the side of decentralization because that is what makes Ethereum different from just AWS, right? Like if it is just about scale, then we can just use AWS. We can just use a centralized database. We can just use some of these other L2s that are not really worrying about all of these hard problems that we are trying to tackle here. That's why we need to err on the side of decentralization to make sure that this network stays the most decentralized, the most censorship resistant, and the most resilient network that we have. And so, yeah, this is kind of where I would draw the boundaries.
Thank you. Does anyone else have anything they want to add? If not, I think we're out of time, and we'll be moving to the next section, which is scaling the L2. Thank you, everybody. Pass back to Ahmed.
Yep. Yeah, so that was exciting. L1 scaling is back on the priority list. That doesn't necessarily mean that the rollup centric roadmap is gone or anything like that. Do you, like Tony, if you have like one question before we move to the L2 scaling, like what happens now with the L2 with the rollup centric roadmap? Like, is it gone? Is it like not anymore the priority? What happened with that?
No, I wouldn't say so, because right in a few hours we will ship a huge feature for the L2. So the rollup-centric roadmap is definitely still a priority. Of course, there are other priorities too, like scaling the L1, making sure that L1 will become this this settlement layer for DeFi especially, but basically for everything that has like that wants to use L1. So I think they can coexist. So we will always need rollups in order to actually get like the massive scale. But on the other hand, we will also focus on the L1, because L1 should also be the hub for many different things that want to stay on the L1. So I definitely think those two things can coexist and will so in the future.
Yep. Thank you, Tony. So yeah, moving on to the next section, which is L2 scaling. Here we have Putos from the Prism team. We have Terence also from the Prism team, and we have Ben Adams, who's the co-author of the one of the AIPs. So there are 3 AIPs for that focus on the L2 scaling. First one is PureDAS, and with PureDAS allows us to increase the number of blobs that can be posted to Ethereum and can be retrieved through the network through sharding. That's one. And then we have BPOs, or blob parameter specific forks. And this one allows us to actually increase the number of blobs without a very large change, or like a very large hard fork, right? It's still a hard fork, but we can do like miniature hard forks that just increase the number of blobs that the network can support. And the last one actually adjust the pricing of the blobs to actually match or be relatively close to the pricing of the execution. Yeah, so let's start with the round of introductions from our guests. We have also Gustavo from the head of engineering at Tyco. So yeah, like Putos, start with you.
Hi, I'm Potus. I'm a software engineer at Prism. I had very little involvement on Fusaka. I've focused my work in the last couple of years for Amsterdam.
Thank you. Yeah, Terence.
Hi, I'm Terence. I'm also a software engineer at Prism team at Option Labs, and I also have zero involvement in Fusaka.
All right, thank you, Terence. We have also Mark from who's also known as Dreamer from the Lighthouse team. Mark,
how's it going?
how's it going?
Yeah, Lighthouse team here. Yeah, I'm just at a hacker house getting ready for the fork as well. A lot of people excited. I also didn't have a ton of involvement in Fusaka this round, but at least some. There was a lot of. I was pretty involved in BPO forks, so that was somewhat
Very cool.
relevant.
Thank you.
Yeah.
Gustavo?
I hope I could change the dynamic and say I had something to do with the hard fork, but I also didn't. But we're a user of some of the features of the hard fork. So my name is Gustavo, Director of Engineering at Taiko, and I certainly hope the rollup-centric roadmap is not dead, otherwise I'll be out of a job. But yeah, excited to chat how Peer does and the other rest of the IPs contribute to Ethereum scaling.
Yeah, thank you. And we've got Ben, who's the co-author of the blob-based fee bounded by execution cost EIP. Ben Adams. I don't know if you already introduced yourself or no.
Hi, I'm Ben. Ben Adams. I work on the Nethermind team, and I like to make things fast.
All right, awesome, thank you. Yeah, so I would like to start with the elephant in the room, which is PeerDAS. It's one of, like the main AIP that is focused for this fork. And I wanted to ask like someone from the CL teams if they can just give us like a quick brief on what does this AIP do, and like yeah, if high level technical perspective. Okay, so maybe start with Mark from the Lighthouse team. Tell us about PeerDAS super quickly.
Yeah, which VIP are we talking about?
PeerDAS starting.
Oh, okay, yeah, that's a big one. 4844. Okay, sorry, yeah. Yeah, I mean, essentially, this is the first round of sharding. Yeah, I know it's not 4844 technically, but this is the first round of sharding that we're in one-dimensional sharding at this point, with the goal to eventually go to 2. So far we've had every node be responsible to custody every single blob on the network. And work we've done in previous forks was to set up all the cryptography, the erasure coding, and things like that, so that we'd be ready for this transition. And now we're getting to the first level of transition, which is one-dimensional sharding. And so we've taken this blob data and we've erasure coded it. So we've essentially like duplicated the data. And then we've also split the data into columns. And now nodes will be responsible for custodying a certain number of columns, depending on how many validators they have access to, but they're not necessarily responsible for custodying all of the columns unless they have enough validators or they elect to do that. And the goal is basically that attesters can now attest to that their attestation signals that they have full custody of just the columns that they're responsible for. And basically the security assumption is that if there are enough attestations that say that everyone on the network has the data that they are responsible for, then there is enough data for reconstruction of the full data. And so we don't have to have everybody custodying everything. That would be my
Right,
summary
so,
in a nutshell.
So for users to understand this a little bit more deeply, so are the nodes like custodying the whole blob, or is the blob itself like getting sharded? Because like you can shard the amount of, like if you have like for example 10 blobs, then some node can have blob number 1 and some node can have number 8 or something like that. But or is it like that every blob is also sharded and each node has a shard of each blob of these total blobs in that are submitted in a single block?
Yeah, so you can think of it like a matrix, and so going, like I said, it's been split into columns, and going across the columns are the blobs. So yes, the blob itself has been sharded, and as you go down the rows, you have an increasing number of blobs. And so each of the blobs has been sharded, and you will be responsible for custodying a certain number of the columns. And so you're holding a fraction of each blob in the block.
Understood. And like from my understanding, like there are 24 columns. This is the number of shards that we have right now. 24. Correct me if I'm wrong. And to be able to reconstruct the blobs, you only need half of that. So you need to have only 12, right? This is the redundancy that you have. So even if, for example, for whatever reason, even though it will not happen, oh, it is 128 columns? I didn't know that.
Unless I'm mistaken, but the last I checked it was.
Oh, maybe
Yeah,
I
think it's 128.
Yeah. So you may have been
Right.
confusing the blob count with the column count.
Right. Yeah. Probably 120. Okay, so it's 128 columns, and then you only need half of those to be able to reconstruct all of the data. So you only need 64 columns out of those to be able to reconstruct the data. So this is like some sort of redundancy mechanism that we have.
Yes.
All right.
Yeah, and that's the idea. And the other idea is essentially every block, in order to be accepted, it has to be attested to by the attesters. And there's always been a threshold number of attestations for a block to have like adequate weight to not be reorged. And the idea is that if a block should reach that threshold number of attestations, then that corresponds to a threshold number of validators having the data that they're required to custody. And if that's the case, that means that we should be able to reconstruct the data. It'd be exceedingly difficult to get a threshold number of attestations without having at least 51% of the data.
Understood. Yeah, that's great to hear. Thank you. So Terence, I would like to ask you about like the networking aspect of PeerDAS. So do you have any idea like what challenges faced the CL devs when they were like working on the networking for the sharding? How is the subscription to each shard or column going on in the CLs, etc.? And yeah, tell us a little bit more about it.
Yeah, so like previously, I had to do a disclaimer. I didn't really work on it this much. All the credit goes to like Manu, Casey, James, everyone on the Prism team. But from what I can see, there was one interesting problem that particularly intrigued me was that, like Mark mentioned, that as a node, you're responded to custody certain columns. And that amount could change given the validator count. So today, if I'm just a node without running any validator, I'm just watching the network. I think the default was 4 columns, but as you connect more stake, you have more validators, that number can changes. I think it was every 32 ETH you times a 4 additional 4 columns or something. And that to me was particularly interesting because say today, if you're a node operator, you are connecting to a bunch of validators. The validators can, for example, swap to different nodes, right? For at time T, you could just have one validator. At time T plus 2, you could have 100 validator. But you were just doing a quick switch over. Then at time T plus 2, you can go back to just one validator. And how do we ensure that like we're sufficiently switching between different subnets, even the validator count and the custody count was an interesting problem to me at this. And I think we're able to do a pretty decent job on that. So I think that's one angle.
Yeah, that's actually interesting. I haven't thought of that before. Yeah, and one other question is like right now, if you want to actually get a blob from a CL node, you can just call the RPC, and if it's the blob will be available to you. So what will happen after Fusaka is that there will be only shards available of the blobs and not the full blobs. So how will the RPC react when you request a blob? Put us if you can tell us more about that.
Oh, we can just like hook an advertisement for Prism actually. That if you run Prism, then you will get the blob if you hold enough data. Perhaps it's because our mother company is a rollup, and we were very well aware that rollups would actually need this. I think Manu was in charge of this part. I'm not exactly certain, but we were sure to support this ability for rollups to query the Beacon API and continue supporting this across the fork, so that rollups can actually still get the blobs from transactions. Rollups are monitoring when they post a transaction. They want to see when their blobs are actually being included, and they want to save those blobs, security reasons. This was actually a problem in testnets. This broke a bunch of rollup operators that were expecting this behavior to continue working on, and it didn't. Either even for any client, if you didn't custody all of the data, and some clients that just we deprecated this, announced it, but there was a miscommunication with rollup operators, and I believe this is being solved now on every client. Mark can probably just confirm this on Lighthouse, but I think this is being solved on every client now. So if you hold all data, you will be able to recover. Meaning if you hold half of the data, you will be able to recover. The problem now is that most clients do not really have flags to really hold less of the data, just enough so that you can actually reconstruct the blobs. And then node operators are holding twice as much as what they need, because the only way that they have now to guarantee that they're going to be able to recover the full blob is by just subscribing to all subnets and custodying all columns, which is twice as much as what they need.
Yep. So just to be clear with the audience here is that if you want to be able to query blobs on Prism, you need to use a flag --semi supernode or --supernode, and semi supernode will custody half of the data, where supernode will custody all of the data, and this is how the CL node will be able to serve the blobs.
You might be more up to date than myself. I'm not sure if we have that flag yet. That flag was being worked on. I'm not sure if that flag was actually released.
Okay, maybe I'm fast tracking this.
Maybe
I'm before my time.
We have Casey. We have Casey here.
I was gonna say there's a fun hack, which is
hi, Casey.
you don't. Hi, I'm Casey. I also work on Prism. There's a fun hack, which is that you don't actually need to control a validator in order to call the Beacon API endpoint that says that you want it to prepare for that proposer. So you can just like give it a list of 64 validator indices, and then it'll adjust your custody requirement.
So there we go, more caller.
Very cool. Thank you, Casey. Yeah, and question to Gustavo, Tycho team. So like I wanted to ask you actually multiple questions. So the first one, like, how do you feel about the blob space on Ethereum? Is it enough? Is that core devs pushing the blob space enough for L2s to be actually comfortable in continuing to use the a blob space of the L1, or do we need more effort in that regard? That's the first question.
Yeah, I think it's hard to say, right? If you see a congestion today, probably the answer will be yes, we have enough. And like I think the complaint from the community has been more on the other side, like these L2s are not paying enough. I think we're still in like pretty much a growth phase, so I think we should continue doing the same that now we're doing with execution, right? Like we scaled to 60 million gas, and if you see the blocks today, like gas prices are down, and that means there's not enough usage, but we anticipate that usage coming. So we should continue to scale as aggressively as we can, because if we think this Ethereum is going to be successful, that means there's going to be a lot more activity, both on execution and data for rollups, right? So I think if we don't scale in anticipation to that, then we'll be running from behind. And when those use cases come or that activity comes and you actually need that data, it will take some weeks or months, probably months, to scale. So I think we should be scaling more, even if we think it's enough today. And that's why we're excited about PeerDAS. And we hope that BOP is like a way to make that quicker, and we don't always wait until the minute we need that capacity to start thinking, okay, how do we get more of this?
Right. Yeah, that's a good answer. Thank you. Oh, and one other thing that I wanted to ask you about is how does like the L2s feel about the blob fee repricing? Like, are like a lot of the L2s actually showed support for this L2 repricing, blob fee repricing, sorry, that is being introduced in Fusaka, because that means that the blob-based fee will have more stability in its price instead of those spikes that sometimes happen on L1, right, Gustavo?
Yeah, I think so. I think we'll see how it impacts the actual market, right? It's kind of hard to anticipate before it hits mainnet. But I think you're right, and it also makes that market more functional, because today, basically, the way you get your blobs included, is you increase your priority fee, so you bribe the builders and the validators to include your blobs, and like that means that the market is not working as expected, and data is just like a very small fraction of the overall price, so you don't actually see the reflection of congestion or anything hitting that. So I think if this is successful, it should make it more functional, especially when you need to include your data in a short amount of time. In our case, since we're rotating our sequencer, that means that a proposer doesn't have like just infinite time to send that block to the L1, which some of the centralized sequencer have more bandwidth to do that. Then we need to land that blobs in a shorter time. And there's been times that we have a higher priority fee, but it's still not getting included. So we have to keep bumping this. And that's why we have today a safeguard where we don't know how long it's going to take. I hope this fix to the market helps with that. And if you pay enough of a fee to include your blobs, then that means you reliably get those included the same way you do with any other transaction. And I know some of the builders also have been working on fixing this and making this more reliable. Because, correct me if I'm wrong, but I think it does impact MEV for people building as well, right? Because if you're going to include blobs, then that means you have to release your entire L1 block earlier. So that's kind of a trade-off they have to make. EPVS fixes this.
Yeah, EPVS fixes a lot of things.
Okay, cool. That's good. I don't have to worry about it.
So speaking of blob-based fee repricing, we have Anders here, who's the main co-author on the EIP and the Ethereum researchers. Hey, Anders, how are you doing?
Hi.
Please feel free to introduce yourself.
Randomly invited here. It's nice.
Yeah, apologies about that. That's an oversight from me. But
no,
yeah,
it's great.
It's great to have you. Feel free to introduce yourself so that the audience gets to know you.
Yeah, so I'm a researcher at Ethereum Foundation. We have a research group called Robust Incentives Group, RIG. And so we deal with sort of, incentives, economics. And so it's sort of the things that we do is sort of suitable for example, setting a reserve price to the blob-based fee as EIP 7918 does. And so I've been working at the EF now for 4 years. I'm doing fee market designs, sort of various alterations of fossil and what am I?
I remember some controversial work that you've done the last fork about minimal viable issuance, if you remember. That was very interesting.
Yeah.
I still think that we
Minimum
should
viable issuance. It's
keep
an
looking.
important thing that we eventually need to do in Ethereum. This is not, it's of course very controversial, but the way things are shaping up is that the ETFs are joining now as well, starting to stake, and we have a situation where more and more stake is added to the network, and we might get more than 50% each staked eventually. And it's not a situation that we don't really like this sort of situation, because it's a welfare loss to the whole system that people are staking just so that they do not get diluted. And the way to solve this is the only way to really solve this is to simply reduce the yield.
Yeah. All right. Going back into topic. So the blob base fee repricing. I wanted to ask you, Anders, about what basis did you use, and explain like the mechanism, super high level, from a super high level perspective for our audience here, about how is the new fee going to be calculated, kind of, and how did you base that?
So at a very high level,
mechanism?
you can say it's basically like this. The protocol asks, is the base fee, that is the execution base fee, higher than 16 times the blob base fee? When this happens, we go into a new regime. In this regime, we cannot reduce the blob base fee any further, because the blob base fee is now 16 times below the execution base fee. At this point, the blob base fee is only allowed to rise, and it can rise. Then it rises with how much essentially how many blobs?
How much extra how much extra above the target?
Yeah, right? Exactly. So if you post full blobs, it rises just as today. But if you post zero blobs, it just stands still, and then in between there, it's just a linear in between there.
I actually have a question. Why is it 16? Is it the relationship with cold data or something else?
This is just something that we sort of agreed on.
Oh, okay, it's just a reasonable number.
It relates to. Yeah, exactly. It's just a reasonable number. It relates to various aspects that we considered. We wanted to make sure that because you have a cost when you post each blob carrying transaction, you pay execution gas, and we wanted the blob gas to be that you have to pay for the blobs to be some reasonable proportion of how much you have to pay for the execution. So we landed on a figure that says like, okay, you still care a little bit about what you have to pay for the blob-based fee, because the blob-based fee is what we are updating with our mechanism. So we want to ensure that users care a little bit about that blob-based fee, so that the demand and supply function still works. And then there was Ben Adams actually on Nethermind. I don't know if he's here.
He's here.
Yeah. So he then came up with a second rationale that fitted very neatly into this whole thing, and that is the fact that when you post a blob, the protocol has to do computations for these KCG proof verification. And so, maybe you want to quickly get into it, Ben, if you have.
Yeah, so there's you have to do like point evaluation, the KCG calculations. So the idea is the execution layer is doing additional work for the blobs that's not accounted for, because posting a blob on the execution side, aside from the tips, is the equivalent to like an ETH transfer. There's no additional cost from a base transaction. So the idea was to link it instead to the fact that it is doing work to confirm that the blob is correct, and then base that execution gas, that min fee on that, rather than at the moment where it's one way, which is like the minimal possible value of ETH. And that also, I mean, one of the advantages of changing this is, so we, as Anders alluded to, it's about maintaining a market structure in blobs. So if there is congestion, that the people posting blobs respond to the congestion, whereas at the moment it has to go up, I think, 1 billion times to even reach 1 gwei, which means you'll be posting blobs, be fully congested, and it'll take like 30 minutes or an hour to get to 1 gwei, which means that nobody adjusts to it, and it may take, you may be backlogged by an hour, which is, Heiko said, is quite a problem. So yeah, and then since we are doing the BPO forks and we're scaling blobs, each time we do that, the market will collapse back to the minimum price. So this change maintains that market structure in some way.
Yep. One question that I have for Alexei on the PeerDAS EIP. What changes did ELs have to make to the mempool and to the RPC endpoint that receives the transaction to support the new structure and the new transactions with the sharded blobs? If you know that.
Yeah, hello.
With the sharded blobs. If you know
first of all, these transactions are now they contain more bytes per blob, like 6 kilobytes more stuff to present columns, right? And it's not a like big increase, of course, but in the future we will be able to include more blobs in blocks, way more blobs. So we took care to have not so big transactions that could be like 72 blobs, for example. It will not be gossiped and accepted post Fusaka. So transactions will be still quite small, and network will be able to handle them. We now need to verify a bit more. We verified just proof and like the second part, evidence or something. Yeah, right. Now we need to validate a bit more. So we have a different transaction of network form part. It means that blob-related data is different, and people who are posting such transactions, they need to take care and upgrade their client code. On the other side, in some clients, it's possible to convert such proofs. I believe Guess even can, and maybe other clients can generate such proofs for you if you call specific RPC method, which is quite convenient. And we need to learn about demand for such RPCs and maybe implement it in every client. Yeah, but when transactions appear in text pool, well, we need to take care about this very edge before and after the fork. So we need to exclude transactions with too many blobs. I guess we need to take care about other things that introduced in the fork, actually. For example, gas limit. So some transactions become not acceptable but they can still be already in the pool. When we build stuff, we need to take care about that too now. More rules, it's cool. I think it will not cause big issues until we will see way more block transactions in the pool. And then we need to take care about maybe about the traffic. Maybe we need to shard or something like that. I think that the networking is problem like we need to take more care about. Yeah.
Yeah. Well, thank you, Alexei. Very helpful insights here on this. And unfortunately, we're out of time for this topic. Thank you very much for all our guests, Kutos, Terence, Mark, Gustavo, Alexei, and Ben, Anders. Very happy to have you here, everyone. And yeah, moving to the next topic, we'll be talking about EIPs that are improving the user experience and the developer experience on the Ethereum network and the Ethereum ecosystem in general. And there are 3 EIPs that are focused on this. So there's EIP 7917, Deterministic Proposal Look Ahead. We have a co-author here for this EIP, Lynn Ushitani. And there is the second EIP, which is Count Leading Zeros opcode CLZ. We have 2 co-authors here, Julio and Ben. And we have also the precompile for CISP 256, our one curve. And we have here one of the EIP champions, Ulash Erdogan. Happy to have you guys. And yeah, let's start with the round of introductions. Ulash?
Hello. Firstly, it was a great stream. I was watching from the Twitter and just joined. I'm Ulash. In professional life, we are building Clave. I'm one of the co-founders there, and we are building a mobile wallet that prioritizes payments, DeFi, earnings, and of course, it uses passkeys for maximize UX and security. And I was one of the co-authors of EIP and RIP 7212, and it now has a new number, but I think the journey is the same, and I have the implementations of clients and the other rollups, and now happy to see that Ethereum is adopting these precompile, and most of the rollups already have for months or years. And thanks for inviting me.
Thank you. Lynn?
Yes, hello. I'm Lynn. I'm a protocol researcher at Nethermind. And should I give a quick intro of the EIP?
Yeah, sure. Go ahead.
Oh, okay. Yes, yeah. So like the EIP 7917, it's an EIP that like fixes one, I guess, like issue that we had in previous like Ethereum, where like in previous Ethereum, the look ahead usually at the start of the epoch, like the next epoch's look ahead, so the proposer schedule of who proposes during that next epoch is kind of deterministic, as in it's like 99.9%, like you know what the next epoch's look ahead is, but there's certain edge cases where that look ahead can change, specifically due to, because like the next epoch's look ahead, it's calculated based on the roundel of the current epoch, plus the effective balance. But the effective balance is actually not about from the current epoch, but it can change within the current epoch. But if the effective balance changes, like the next epoch's look ahead can change, even though the roundel is fixed, the effective balance can change, look ahead can change. And yeah, this has basically been kind of a designed oversight mentioned by a lot of people who were like the beacon chain architects, like Justin Baker and like Danny Ryan. And yeah, like this EIP basically fixes that by like pre-calculating the look ahead and then storing that in the beacon state. And yes, this also helps a lot for base pre-confirmation systems where the L1 proposer provides pre-confirmations to the users, because they're like knowing who the next like opted-in proposer who's willing to provide pre-confirmation is deterministically is very important. That's it.
Thank you. And we have also Ben and Julio for the CLZ opcode. I believe they both introduced themselves previously. Starting, let's also take a round with Ulash to talk about the new curve and what does it enable exactly? Why is this introducing this precompile for this specific curve important for Ethereum?
Yeah, we always hear that Ethereum has a 1 billion user goal, and I think this precompile is a gate for enabling this 1 billion user goal, because now we have 4 or 5 billion mobile devices in the world, and almost all of the new devices, and the research assume that 60 or 70% of these old devices support a curve, which is this P256 R1 curve. And Ethereum had the K1 version of curve. It seems more secure and close for a few of the risks, but now the world adopted a different type of curve, and when it's enabled on Ethereum, everyone will be easily onboarded to use Ethereum. And we can give the example from the web too. Now, Amazon, Google, and most of the big companies use passkeys for authentication and logins. And we see that it
increase that's scheduled from today
removes the risks of some phishing attacks or password change or stolen passwords attacks. And now we are ready for this adoption on Web3 with this hard fork, and it will mean that every user with a mobile device will be ready to use Ethereum directly without having a seat.
Alex, I know people are excited about our
issue with that. Oh, I think I'm back. Okay.
Yeah, it kind of froze for a second, but then it got back working.
Yeah, I was saying that with passkeys, people's device will be ready to onboard their users in a secure way with a good user experience. When you have a device, you have your Face ID or Touch ID to enable your passkey on your device, then it's your only need to receive funds, send transactions, and authenticate yourself in future. And I believe also it was a missing part of account abstraction world from the last hard fork. Now we will be able to have more strong accounts with better UX, because you won't need to care about your seed phrase, and it will be more secure as the hardware wallets, and we may see more use cases that replaces hardware wallets or maybe MPC solutions in a more secure way.
Yep. Thank you for that. And yeah, very useful AIP indeed. Thank you for pushing for it. I remember you kept messaging me and messaging a lot of the core devs, explaining the importance of including this AIP, and this had a great role in actually getting it included finally. So thank you for that.
For your supports.
Yeah, of course. And yeah, Lynn, if you can just tell us super quickly the deterministic look ahead EIP. what actual benefit to the users does it bring? Like even if it's an indirect benefit, how is it beneficial to the Ethereum ecosystem in general?
Yes, so I think like now that the CIP is included, like it's now up to the so like one of the things that it, as I mentioned before, is like that it enables base pre-confirmation systems. At least it like basically simplifies the design of doing those. And so yes, and if you have a base pre-confirmation system, like the proposer in the lookhead can provide you pre-confirmations, so they can opt in to provide certain pre-confirmation, opt into certain pre-confirmation protocols and start providing pre-confirmations. There's like various different kinds of pre-confirmations. Like one pre-confirmation that we're working like with the Taiko team actually is like to bring base pre-confirmations on top of Taiko, which is a based rollup. The based rollups are rollups where the L1 proposer are the sequencer for the L2, so you don't have a centralized sequencer that lets the L1 proposer also sequence the L2 transactions. And yes, like to enable like let the L1 proposer sequence L2 like transactions, then you need them to opt in, and like the next proposer who's opted in the lookhead can provide pre-confirmations on top of a based rollup. So, and yeah, I think like decentralizing the sequencer has been like a long-lasting issue that Ethereum had for a very long time, and like the credible neutrality of a centralized sequencer has always been in question. So I think it's great that Ethereum L1 can act like as a decentralized shared sequencing layer for Ethereum. I think that's like a huge cool thing. And yes, like there's also like L1 pre-confirmations that I'm less like working directly on, but it also has like some cool things that come. Like it's harder to get execution pre-confirmations which guarantee the exact execution, but there's inclusion pre-confirmations which can ensure that a certain transaction is included in a certain block. Yeah. My dear.
Yeah, so in simple language, so for our audience to understand it in a simpler way, it basically the CIP enables decentralized pre-confirmations, which basically brings user experience like fast confirmation. When you submit your transaction, you don't have to wait 12 seconds or 20 seconds for your transaction to be included. You get a pre-confirmation, and that pre-confirmation is provided to you in a decentralized manner. It's not a centralized sequencer that is providing you with the confirmation that your transaction will be included. So you keep the decentralization of sequencing through the base pre-confirmation, and at the same time you get the fast response from your RPC provider or from your wallet that your transaction is confirmed. Yeah, thank you, Lynn, for the explanation. And yeah, Julio, can you? I don't know if you're available to give us a small brief about CLZ and what does it bring to that developer experience or compilers or the users of the Ethereum ecosystem.
Sure. Yeah. So what the CLZ OP does is essentially just implement an OP code that returns the amount of reading 0 from the first element on the stack. So essentially, in simple terms, it allows for certain operation to be faster. Some examples are bitmaps, but it also improves a lot the life of some ZK stuff, which because in order to prove certain because counting the leading zeros of a certain of a certain input is actually quite common in general, and there are many places where this is used in, say, ZK, in smart contracts, and especially in ZK, proving stuff is very expensive, and proving counting leading OP code without the OP code is also very expensive. So it's kind of a fix for that. But most importantly, it makes certain smart contracts takes way less gas, essentially. So it makes the developer experience much better, I would say, and allows for the creation of more efficient smart contracts. That's, I think, the gist of it.
Yeah, thank you for that, for the explanation. And yeah, so one, I think this covers, yeah, this pretty much covers most of them. Oh, yeah, so we have Mark here who has potentially worked on the deterministic look ahead from the Lighthouse team. Mark, can you give us like if you guys faced any challenges in implementing this? Because I know that to get the deterministic look ahead for the proposer duties, you have to include it in the state, and also there was potentially, luckily, there wasn't really a change in the structure kind of the state, because the size of the look ahead did not exceed a certain limit. But if we exceeded that certain limit, then we would have needed stable containers so that not all of the applications that depend on the beacon block route would be broken, right? So if you can give us just a quick rundown.
Yeah, so for us, due to the way we structured it, it was not a whole lot of code to put it in. Like the diff was quite small, and just like just including it, let's say minimum viable amount of code was very small. But part of that had to do with like the way that Lighthouse is already structured in the code, and that adding stuff to the existing to the beacon state into our existing consensus data structures isn't too difficult. It's a couple lines, but there was some troubles with the way that this fork renamed certain functions. Like we had already been using those names internally, and then all of a sudden those became something that was part of the spec that wasn't the way we were using it, and so there was some weird like name confusion there, and some interactions with our like caches for previous forks that were a little funny. But that was just kind of growing pain stuff. And let's see what your other question was. Really, it wasn't too tough to implement on our side. In regards to stable containers, yeah, like so we have these a lot of applications in Ethereum need to prove stuff about the state of Ethereum, and they use Merkle proofs to do that. And the problem is with the way we have set up the way we Merkleize data structures on the consensus layer. When you cross like powers of 2 numbers of components in a structure then you end up like reorganizing these Merkle proofs, and so on-chain code that requires the Merkle proofs to be a certain way now suddenly has to be replaced in order to work with the updated version. And that's where you get this stable containers idea, where we will change the way those are encoded. Contracts will update one time for this new encoding, and they will never change again. But it is something we plan for a future upgrade, but including it in this fork did not cross a power of 2, and so it wasn't like we had to this time. But yeah, stable containers is on the roadmap and something we anticipate having to do.
Right. Yeah. Thank you very much for that. And yeah, so this marks the end of this section. Thank you so much, Ulash. Thank you, Mark. Thank you, Lynn. And yeah, thank you again, Julio, for being with us for this. And yeah, so it's almost 5 minutes till or even 4 minutes till the fork. We'll start looking into and monitoring the tools that we usually monitor here. Start sharing our screen. And yeah, while my colleagues are starting with this, and Ben Adams is preparing, I wanted to ask Marek, as the head of a blockchain engineering at Nethermind, how is he like? How did the Nethermind team perform implementing Fusaka and their contribution to the fork, etc. Like general, if he has any feedback.
Amazing.
Feedback.
Amazing. I'm always proud of my team, so nothing more to say. Yeah, we are getting ready also for Glamsterdam. We recently passed Glamsterdam test for block level access list. Huge shout out to Mark Harvey from our team. Yeah, amazing work.
Okay. We have less than a minute to go.
Yeah.
You can see, so this is the live state of the EL node using the Nethermind UI. We can see the transaction coming in for a block.
This is the first stream that we showcased the Nethermind UI.
Is that?
It is.
Yeah, so this is the order of the transactions by priority fee, and then the color is the amount of gas they used, and this is the mempool flow. Although a lot of transactions go via the not the mempool, the private order flow. And then we have the lab from ETH Pandarops, which shows some of the nodes that opt into the their addition. You can see where the attestations arrivals, where they're coming in the world, and then this is the door of the Explorer. How close are we?
We are.
Oh, we already there.
Before.
Okay. So we have a missed slot. This is
We have a missed slot in the first the first slot was missed.
But we do have a proposed block after the slot. That's good.
Yes.
Okay.
Do we have any CL logs somewhere?
Okay.
Where we can see CL logs, where we can see the mascot for the fork. Do we have that? The giraffe. I want to see the giraffe.
Do you have that, Marcus?
I can show my screen with many seals. As
Go
many
for
as
it.
you want.
Go for it.
Yeah, let's do that. Let's do that.
Do you see my screen, guys?
Whoa.
Yeah, true DevOps.
Yeah.
This is DevOps.
Right.
Yeah, we have a few giraffes over here. You have
Nice.
Lighthouse as well. You want giraffe? There you go.
It doesn't end.
Very nice. I mean, it doesn't look like a giraffe, by the way. I don't know. Does this look like a giraffe to you guys? More like a,
like a
zebra, but I don't know.
We fork. It's fine.
Mark, we can't hear you. You're muted, but we'd love to hear you.
Revert the fork. We used the wrong animal.
Yeah.
Wasn't Pectra zebra? As far as I remember, Pectra was zebra, right?
Pectra's, or yeah, I don't remember what.
I think Pectra was zebra.
We run out of animals.
Or developers were just lazy and copy from the previous fork.
Finally, just now put together that our ASCII for Lighthouse has columns, like Greek columns, like blob columns.
And I don't understand the Nimbus one. like lion or
tiger?
so. Yeah, tiger. Yeah.
Maybe it's hunting giraffes or zebras.
Yeah.
What's that red that we're seeing? Is that
No, that was
something?
it was just a debug request.
Ah, okay.
Ben, would you like to share your screen with the UI and the other components?
Yeah.
Okay. So you can chain working.
Beacon chain is delayed for some reason.
Okay. So we are still producing blocks, still transactions coming in.
It's the boring fork, it seems. Let's hope so.
Wow. Wow. Well, there was obviously a mascot problem. I don't know. We're going to have to dissect that.
Post-mortem.
Okay. So
Boring
still
fork is the best
testing.
kind of fork.
Certainly
Yeah,
is.
100%.
We're getting a couple missed slots, but looks
Hopefully
like
just some validators didn't update their software.
when's that? 49. Okay, so we're still waiting for this one. It's this one, isn't it? Epoch. So we're waiting for that to justify. Well, it's not finished yet. But it looks like retail participation. Where? On this one? Yeah. Yeah, so we've got good participation. Oh no, this is post-book, is it? Binance missed one earlier, but they've now proposed. So hopefully that's a good sign.
Yeah, but Beacon chain, the normal side, not the light one, is down. It's not like a sync.
Oh yeah,
fork.
5 minutes ago. So maybe they forgot to update their software.
Imagine. I mean, yeah, probably.
But yeah, Dora's still working.
What is the participation right now?
I mean,
80% and still counting.
Yeah.
This is 85 already.
Okay.
So we'll know soon, but it's still aggregating. 88.
Yeah.
Yeah, so it's looking good.
Still growing, still growing. I expect we'll hit way over 90 at this point. 91.
And we've just moved to the next epoch.
Yeah, but
so the first one's missed.
Still
94.
Aggregation
Yeah.
should still rise.
It's still aggregation, yeah. It's still aggregating. We've reached 94 up until now. 94.6.
Yeah, 94.6 exactly. It still should go up.
We justified the epoch.
Yep, justified.
Couple missed slots again. The BPO goes live in 5 days, where the blobs are increased to 1015.
Looking at our nodes, none of them crashed in any way. Every single node is processing properly. Just one node wasn't upgraded properly. For some reason, didn't pull out the proper image. Right now, bring it back up. It catched up through the blocks which it marked previously invalid, so it's all good. I'll already process the transition block.
Is there any blob price change that can be seen?
Not really, surprisingly.
It shouldn't be, right? Because we have the same capacity.
Yeah.
And also, I think it will take a while for the rollups, even when we increase capacity, to like switch over their internal systems to use the increased capacity.
I mean, it shouldn't go down from two-way.
It's at 4.
Okay. I suppose.
Shouldn't go down anymore, right? So it will be just increasing slowly.
Yeah. No, up to a point.
Yeah. Yeah. Right now at 5.
Interesting stats. Our stream has more viewers on X than the Ethereum hosted one.
You're muted, Mark.
Maybe he's talking to someone at the hacker.
Oh,
You talking about me? Yeah, I was.
I think the attestations will kind of flat out around 95%. So that means that 4.5% of the network didn't upgrade correctly, which is kind of standard, but yeah, kind of standard from my recollection, but still a bit disappointing that 1 in 20 nodes didn't upgrade.
So again, what is the percentage of?
Around 95, almost 95.
But you need to wait for the finalization, right? Then the number on Dora might get updated.
Yes, maybe it will still go up. We'll see. Let's wait a bit more.
Well, looks like Anna will come back. No.
You can see for sure more missed blocks, but 5% seems quite good too.
Okay. We can change. We'll come back.
Just we are having quite a lot of blocks which are having 9 blocks, then followed by quite a few with 0 blocks, and then again 9. So it fluctuates quite a lot.
Yeah, I'm seeing also the blob price rising.
Yeah, the block price is rising, but what I mean is not number of blocks. Once you have 9, once you have 0, 9, 0, 9, 0.
Yeah.
That's one of those. Yeah.
At 8 right now.
And 3 transactions. Base. Looks like the under slabs.
Has someone written down the exact block number for the fork? I didn't. I can't find it.
Could be the first one in this. I don't know. Okay.
Should be finalized
Oh,
soon.
It's finalized. Yes,
Yeah.
it's finalized.
Okay, well done.
Just finalized.
And participation on the next epoch is almost 96% already, so rising back up.
Yeah.
Yeah.
Not so fast. Well done.
Well done, guys.
Happy Hard Fork Day.
Yeah.
Go again. I should stop. I think.
Ben, I just wanted to mention that you have nice flags because I seen that one gigagas there somewhere. Near logs.
I can check. You mean the fire?
Yeah.
Next epoch is already 95.8, so already 1% regained.
Yeah, so it's higher than previous. But maybe some people have suddenly upgraded. Okay, I think I'm handing over to Mark on Ethereum after Fusaka. Mark?
Hello. Do we have Mark and Thomas here as well?
Hello. Thomas is there as well.
Hey, yeah, I'm here.
Hello.
Oh, great.
Great to be chatting to you guys after what hopefully seems to be a successful hard fork. Don't want to jinx it, but so far so good.
Yeah, the numbers look good. Obviously, many people will be looking at those numbers for the next few hours.
Yeah, it's quite interesting to see how the kind of blob gas market will evolve with the new like min blob base fee and kind of how that's going to change things.
What will be the number that you expect to be the new minimum?
I mean, it's kind of impossible to say, really, isn't it? I mean, it's kind of
it's related to the gas price on the execution layer, right?
Yeah. But even though, I mean, that seems to be very low at the moment, but even then, like, it just depends, where the equilibrium kind of falls, doesn't it? Like, it's kind of hard to predict, but be interesting to see. Yeah, so getting into this segment, this is kind of focused on Ethereum after Fusaka. So looking ahead at the kind of future upgrades in the pipeline. And I thought we could start off the discussion with Amsterdam. And kind of what do you guys kind of think are the most important changes coming up in the Amsterdam update?
So I can go first. So for me, Amsterdam is a layer 1 scaling fork. Fusaka was more focused on layer 2 scaling, while Amsterdam will be focused on layer 1 scaling. So we will have block level access list, which will allow execution clients to execute blocks faster, and in parallel, we will have very likely some gas pricing, which will also allow to reduce bottlenecks, to reduce worst cases, and EPBS, which extend the window for block execution. So everything related to scaling layer 1, which is super great.
Yeah, I think that looking at the fork, at the people selecting EIPs for Amsterdam and then soon for the next fork as well. What's most important for me is that
the process gives flexibility to follow the focus areas that the entire ecosystem is pointing at. So we hear about finality, we hear about scaling. I mean, the entire this year, we were talking about scaling L1, L2, scaling blobs, improvements to UX. So it's very encouraging that we managed to find a few tracks that were clear for everyone, and that core devs and researchers together could focus and find, say, relevant upgrades. I've seen lots of collaboration towards Amsterdam. I've seen great effort from the client teams and the interrops. I've seen researchers being extremely focused on delivering things that are shorter term relevant. We've been facing some criticism of Ethereum ecosystem, in particular Ethereum Foundation research, to be a bit too long-term focused in the last 1 or 2 years, or even before. And there was this a bit quick adjustment for Glamsterdam, for practically from Pectra, Fusaka, Glamsterdam, adjustments to focus on a few things that were quickly resolving the most burning questions from the blockchain users. I love it that there is this sense of caring about the entire ecosystem, about the L2 scaling, about L1. I think that we gave some upgrades to the ecosystem that make everyone happy. Like they understand that there is a promise of scaling L1. They understand that if they build on L2, that L1 goes, like side by side with the L2s on the scaling side, so you can rely on the long-term commitment from L1. If you're planning to build on L1, that you can also deploy very safely and predictably the high-value, high TVL DeFi, the identity systems, the highest value identity, highest value NFTs, and so on and so on. We've seen a lot of stablecoins volume flowing through L1 this year, and I think it's great to see that there is a commitment from the Ethereum ecosystem, from the core devs to deliver scaling for the payments and settlements going through L1. Yeah, and also, between Amsterdam and Fusaka, we have the blob scaling, the progressive block scaling. So that will be great to see as well. We've talked to many L2s, and they were already excited about utilizing the increased block count. We're starting to talk at the foundation about how we now integrate the long-term and short-term roadmaps. We talk about convergence of Lean Ethereum and the ACD roadmaps. Want to precisely describe these roadmaps, the paths, the possible paths, how they address maybe not the issues, but the needs that we hear about from the ecosystem. So I think that also there is more and more maturity in the process without going bureaucratic with the process. So we'll see if we can maintain it and keep improving. Then I'll be extremely proud of the all core devs and other operators and tool operators collaborations.
I think you mentioned again that those 3 main goals that we talked about after Pectra as well. So the scaling L1, blobs, UX. But do you guys think, or what do you think maybe is the point at which any of those goals become more important than the others, or we start to kind of reach a point where the goals shift, or do you think we're still quite far from that?
So the discussion happened all the time. We announced that around May or June this year, and we expected this 1 year of goals or maybe longer term, which means that really until Amsterdam, these are deliveries of these 3 focus areas. We asked a lot the ecosystems, the builders, cypherpunks, and inside in Ethereum Foundation, we discussed it a lot of do we feel like those focus areas are changing? And when there were proposed changes, then usually there was also pushback from our integrators that no, we still think that the existing paths are the most important. So we most likely want to propose, but it's still under discussion. We want to propose to the ecosystem the merge of the scale one scale blobs into a single focus area that will be called scaling. So we'll be talking about Ethereum scaling in general, and we hope to continue delivering scaling. It means that we probably will start talking also about the aspects of scaling that are much more long-term, zkVM, the more advanced, sophisticated PeerDAS. So the layer for the future of L2s. What else is that maybe we'll start talking about going even more extreme to follow the $1 trillion security of jumping with the security considerations much ahead, years ahead. Talking about post-quantum security, talking about all the crazy edge cases of the large-scale attacks and recovery modes. So a bit of running testnets and running a bit of chaos monkeys on those testnets. So this might be the area where we put more budgets to help to coordinate.
Yeah, so I guess the question for both of you is, do you think that with Glamsterdam we've started to move in the right direction in terms of kind of fork scoping and the cadence of forks? Because I mean, it certainly seems more streamlined than Pectra, and hopefully we can keep that up.
So I think on my side there was a sorry. I'll try to quickly respond. I generally would love to see a very, very clear cadence of the forks with the precise timelines and long-term expectations that would deliver predictability to all the core developers, testers, researchers, coordinators, that they would know when the forks happen, and then they would assign the amount of work to particular timelines. But we have it as an open discussion. So I think that there are different approaches like fork when it's ready, or fork that is meaningful, or fork when it's scheduled. So we may expect maybe more discussions on this topic, or maybe Foundation will define within its coordination role the timelines. Why we'll be simply leaving the list of items that go into those scheduled forks to the core developers on the ACD.
And maybe I want to add on top of that. So from client team perspective, it's always nice if we know upfront what will be added to the forks. So it will help us with our development, our plans, what we need to prioritize, and so on. So I think we are keep improving on scoping forks, but I hope that it will be even better, and that fork will be also more predictable for community as well. Yeah.
Thanks, guys. Yeah, another thing I was thinking about is, so I saw Vitalik tweeted the other day, kind of like a picture of the L1 gas price and how it's kind of dropped after jumping to 60 million gas. And he was saying, like it's time to, build on the L1. So I kind of want to get you guys' opinion on that. Like, when is the right time to build on L1, and what would you kind of say to like the sort of straw man an argument, like if we're going to make it so cheap on L1, like do we need the L2s, or like why do we still need them, and kind of what purpose they serve relative to each other?
Of course, we will always need L2s, because L2s will always be designed to go far, far beyond L1. But at the same time, we're inviting more of like sophisticated, high-value DeFi to keep building on L1. When you go to talk to DeFi builders across all the blockchains, they say, look, we're deploying on Ethereum mainnet because that's where liquidity is. That's where we see the biggest impact on the results of our protocols. So they go there naturally. And I remember probably around 1 year ago, if you went to DeFi people, they were starting questioning how safe we are long term on Ethereum mainnet, and that was just like maybe not misunderstanding, but there was a wave of criticism towards mainnet not scaling. But I think now there will be lots of visibility of very long-term commitment that the core development community will always be able to push the limits on the scale on the L1. We can expect it to grow with the progress of the network capacity of the of like CPUs, GPUs, powers, and so on. So coming back, why you built on L1s for highest value, closest liquidity, composability, for absolute top security and never downtime, and you go to L2s for acceleration of like the super low cost transactions at the very low latencies. Like the Ethereum mainnet will always have slightly higher latency because of the mainnet supporting the global settlement for particular topology of the network. It supports all the sovereign nodes and will always have delays, and it's designed to allow nodes to participate from around the world. And we still start talking about decreasing the slot time, so it might be 6 seconds, maybe we'll go slightly below that. Somewhere there between 2 and 4 seconds, I think, is the limit of what we want to see for the global settlement layer. And the L2s will always be going with the with either something regional or something city scale. So if you have collocation, some specific L2 that's maybe per trading, think of Lighter, think of Mega-Eve, think of Rise, and a few others. So they'll be going for 20 to 50 milliseconds delays or even less. The regional chains will continue thinking of like 100, 200, 300 milliseconds, and they'll be representing more like trading hubs, maybe in North America or Europe or so on.
So kind of to think like on a maybe kind of longer term issue, where do you see the like post quantum kind of transition coming into things? Because obviously we have like the shorter term focuses, but it kind of feels like we have this thing sort of looming over us in the next few years. And kind of, I guess, question to both of you, like, how urgent do you think that should be?
So we have the designs for post quantum security. We understand that much of the aggregation logic, there various aspects of post quantum security are much more expensive in the context of data requirements or compute requirements. This is all being worked on by the Lean Ethereum team, and we have there, I think, 15 core development clients, which are many new participants in the space of the Ethereum infrastructure, working on post-quantum security and general more significant changes exploration for the Ethereum protocol. Now, to bring that faster to Ethereum mainnet, we are starting now to integrate and coordinate that integration at the Ethereum Foundation side to present how the roadmap could look. And we hope that we'll bring it to all core devs very soon for discussion. So finally we have Lean Ethereum coming to that ACD space. In the past, you would see Justin Drake and people around him to really almost feel like they're working on something different than the Ethereum canonical mainnet solution. I think that maybe that's how the merge looked in the past. I'm pretty sure it will look very different in the merge. You're not building another chain and merging them here, but you're proposing a series of significant changes together, and then we'll probably review of how exactly they gradually integrate to Ethereum mainnet. And post-quantum security will be very, very big topic there, and we can expect something within the next 3 years, most likely, gradually and addressing all the concerns.
Oh yeah, Marek, do you want to say something on?
Yeah, I think Tomasz covered this topic very well. I think post-quantum security is very urgent. I cannot say more than Tomasz here.
Yeah, no, it's nice to know there's lots of people kind of thinking on it and like working for a few years ahead. Yeah, a question for you, Marek. So I guess looking even further ahead, are there any changes you anticipate in the Heka Bogota fork, or is there anything that you would personally like to see?
I would really like to see a shorter slot time in Heka, and I think it is totally possible. Yeah, and this is one of the main things, and maybe something related to gas pricing. So to scale layer 1 even further, we will see what we will have in Amsterdam and what we will be not able to deliver to Amsterdam and ship in Heka then. Maybe in Bogota, but this is like big question mark, something around statelessness, maybe something for ZK as well.
No fossil?
Of course, fossil. Sorry, Mark, because you are working on fossil. So fossil for Heka, in my opinion. So after Amsterdam.
Yeah. I think personally, fossil and fossils were my favorite, but then 6-second slot times I think is very important as well. So hopefully you could see both those go in, but yeah, we'll see. So how do you guys kind of envision Ethereum's transition to ZK clients, and kind of how do you think the ecosystem is going to change, and how is it going to look in terms of the kind of nodes that people are going to use? How's it going to look?
So we will have very heavy block builders with huge GPUs and so on. They will be building ZK proof that then later will be verified by people on smartwatch, on smartphone. So right now we have just one type of node on decent hardware, but consumer grade hardware. And this will change a lot after ZK. We will have very sophisticated block builders, more sophisticated than they are right now, and we will have users that will be verifying the chain on smartwatch. Of course, I guess we will have some people that will be running for full nodes for RPC and other stuff, but yeah, this is how it will look like in the future.
Yeah, I think a good description from Marek. I think that we start also talking about aspects of storing data, about the like archive indexing nodes, what we'll have to see there. So there are many different types of users, and we'll have to list those types of users and see what kind of infrastructure they'll be operating in the post-ZKVM world. And what kind of capacity we can expect. I'm definitely super excited about the ideas of like client-side verification on very lightweight machines. It may open a lot of new ideas on how to build applications on the edge devices. So more verifiability for Ethereum chain means that you can build apps that maybe even exist in some kind of offline P2P networks with very, very rare connection to the internet. So.
Yeah, I mean, Justin Drake showed a very nice demo at ETH Proofs Day in Buenos Aires, where he showed actually like a consensus layer client actually downloading those proofs and verifying them instead of using an execution layer client alongside it to actually verify and attest to the blocks. Of course, because of the proving delay and there is no like pipelining for the station. That the station arrived late because like of the proof taking around 8 to 12 seconds to prove the block, where you actually need to attest around like 4 seconds after you receive the block for your attestation to be included. But it still landed and it's still attested. And like so it is a very cool demo, but at the same time it made me realize like, okay, we really need to have those different roles for different actors on the chain, because if all the validators right now started using this to do attestation and started depending solely on MEV and MEV boost and builders and relays to build blocks, then we lose the fallback to local building in case those centralized actors like relays and builders fail at any moment of time, and then that affects the liveness of the Ethereum network. So we need to be mindful of decentralized actors and make sure that the Ethereum as a chain liveness does not get affected if certain infrastructure fails, and if we switch to such approaches by actually having those specialized actors in the staking and the validators. One topic of research that is actually addressing this throughout the past couple of years is actually APS, a tester proposer separation, which is the Ethereum research team has done some quite interesting work there.
Yeah, I guess Thomas, do you have anything to say on that in terms of like do you see it as kind of a problem in terms of if we have like very heavy builders like provers, what is the fallback mechanism for that, or kind of how heavy can it be in terms of like GPU usage, or are there some solutions here that people are looking into?
Well, so far we need, so far we see the 45 million gas blocks at real-time proving, and with the adjustments in Amsterdam, we should also address some of the edge cases for proving, and then it will be a race of how far we can go with the real-time proving. It's parallelizable. We support now more parallelization on the block sizes with the transaction size limits. So probably going into like few hundred million gas and then beyond. If you listen to maybe Justin Drake's expectations, they're going very far. And I historically am quite positive about Justin Drake's expectations. Many people think that they're very optimistic, but we're looking into it, and the ZKVM teams are obviously slightly skeptical sometimes about some aspects of it, but usually they look and deliver later, and so far they were beating our expectations on the ZKVM side. Will there be powerful machines? I think go back to many predictions on how block buildings will look in the future, whether it's the end game, the block building itself, and you asking about fallback. Yeah, I think that it will be always the stage of testing when we start experiencing that world with very sizable blocks in the block proving. That we'll think what happens if the major builders like somehow got shut down, attacked, or whatever, and how the fallback mechanism will be designed. I think that simply the core devs will detect it as very natural possible failure scenario, and there will be some kind of very plausible degradation of the network that will just support liveness. It's always in Ethereum space. We're talking about liveness here. That will be prioritized. So no downtimes ever.
So my small dream here is that even if we have these sophisticated block builders, I will be able to go to hardware store and buy very expensive graphic card, very expensive hardware, and maybe build some block, maybe not that profitable as those sophisticated actors, maybe having less transaction inside, but being able to build this block in at the end of the day. And that would be great if this is possible.
Yeah, and the prover markets will be most likely decentralized. And nowadays, when you look at the cost of proving a block, it's like a single-digit cents, so it's extremely cheap.
Yeah, and we might also see like a separation between the block proposer duty and the block prover duty. So like you might be able to build blocks, yeah, and then delegate the proving to a prover auction or a prover market. So yeah, that's very likely, because also one of the requirements for actually verifying those blocks is that you get multiple proofs. So in Justin's demo, he did not depend only on a single proof to attest to a block. He waited for at least 3 out of like 7 proofs or something like that until the CL client was like, okay, we will attest to that as a valid block. This marks the end of the stream. Unfortunately, we're running out of time, guys. But it was really great to see you all and to have you all over here. And yeah, thank you very much for all of the audience. Thank you for all of our guests. Thank you for the core devs who have worked on Fusaka and made it a success. Thank you to all of the support team in the Ethereum Foundation that made sure that the core devs can deliver this. And good to see you, and see you in the next fork.
Thank you.
Cheers,
Bye.
guys. Bye.
Thank you.